So, first order of business. Some of you may have thought that this is a Gen AI production kind of talk. There was a mismatch in the communication, and I was actually asked to talk about prompt engineering, which is a different topic. It's one of my most successful talks and lectures in our workshop and also on YouTube. I think we're almost at 10,000 views. And today I'm going to be walking you through how to do prompt engineering, as the title says, from zero to hero. So, a little few words about myself. My name is Jonathan. I come from a background in software engineering, leading R&D teams. In the past 6 years, I've been a sales engineer, AI ML specialist at Google. And as Adam said, in the past year and a half, I co-founded Latent. We are a professional services shop, do hands-on development in AI. In the past year, we've grown to 15 people. We've put over 20 projects in production. And all of what I'm going to talk to you today is based on stuff that we've seen and learned. Obviously, there's a lot more to cover than we can be done in 30 minutes, but we're definitely going to get a good taste of it. Last thing, my deck isn't very long. I don't believe in having too many slides. I'm very quickly going to switch over to my IDE and show a lot of examples. I really believe when we're teaching, when we're trying to convey a subject, it's good to see what doesn't work and how using the technique actually makes things successful. So, why are we here? All of you are, to some extent, already doing generative AI, and it doesn't really matter if you believe that AGI is coming or isn't coming. If you believe it's coming tomorrow, you're probably not sitting here, you're probably in option one, sipping margaritas somewhere on the beach. But if you're sitting here, you probably want to learn how to do prompt engineering. I always love to use the analogy of how important prompt engineering is, very similar to when emails came out. I remember 15 years ago, I started my career at Ironsource, a high-tech company, and I wasn't a very good offline communicator. I had to learn how to write mails to efficiently communicate, and the better I got at writing those mails, the more productive I became, the more relevant I became, which is very much what prompt engineering is becoming today. If you want to be effective, if you want to become productive in your work environment, you have to learn how to extract maximum value out of these LLMs. It doesn't matter if it's ChatGPT, if it's Perplexity, or if you're building an actual LLM application using RAG and stuff like that. The basis of the new world is knowing how to prompt engineer. Now, doing generative AI in general is very, very hard. A lot of people just go into ChatGPT, they have a POC, they do a small POC, maybe they have an idea, they throw it in ChatGPT and they say, create me this YAML according to the following specifications. And it seems to just work. Or let's say you want to do text to query, which we're getting a lot of lately. You just take it, you say, build me a valid SQL query, you copy paste in the schema, and it just kind of seems to work. In reality, getting all the way from POC to production is hard, and for good reason. If we're focusing on prompt engineering, which I say is the basis for everything, it's hard because I love this example. Every different word that you put into a prompt can make a difference. Now, if you're writing a 65-page long prompt, maybe you're not going to see it. Maybe not every word is going to be as detrimental to what you're doing. But point in case, this is reality. If you're trying to talk about current, and I also love this example because it works both in Hebrew and in English, זרם חשמלי ו-current electric, זרם בים וזמנים עכשוויים. If you just write current, you're liable to maybe get a sentence or a paragraph that discusses any of these. But what we essentially want to do when we're prompt engineering, we want to end up in the subsection of relevant answers. if any of you have heard like the topic of hallucinations, basically anything that's not discussing electric in this use case, which is what we're interested, is considered a hallucination, and it's our job to make sure the prompt arrives at the relevant subset of answers. Now, everybody knows that LLMs are next token predictors, and this capability is generally amazing. And if I haven't convinced you how impactful it is, 1, 2, 3 is just the example of how it works. It completes the next sentence. We'll see a demo of that in a minute. And I love this example by Jensen Huang, who is the CEO of NVIDIA, where he describes the importance of just predicting one word the following way. He says, if you don't think that's incredible, take a mystery book, let's say a one by Harlan Coben. The books are normally written in the format that you only find out who the killer is at the end of the book. Eliminate that word, let an LLM take the input of the entire book, and it always gets it right. If you're a human, to do that will take you a good couple of hours to read the book, depending how fast you can read it. Now, prompting. How does the process look in practice? There's a lot to be said about how to do prompting, and there's a lot of kind of toolings to help you do prompting. And I could have probably written a list just detailing the process, 7 steps, going back, repetition, and everything. But I like to boil it down to make it simple. Prompting is an iterative process. It's a trial and error process, and it's also non-linear. What do I mean by that? You write a prompt, you try to achieve a goal, it achieves that goal. You add another objective, maybe another layer, maybe another constraint that now this prompt has to achieve. You move a step forward. You add another something breaks. It's not always moving forward. A lot of times we work on use cases by customers, and there's like, let's say 30 things on the roadmap that we want the prompt to be able to produce. Because let's say we're building a text to SQL or text to YAML, and there's 30 different parts of the YAML that we're trying to build. It would technically be awesome if I could just like do them one by one by one by one. In reality, you do 1, 2, 3, 4, 5, and then number 6 kind of breaks number 2. And you have to go and now solve the prompt for both of these things together. And one really, really good practice, such a good practice that I've recently put it into like my basic structure, is if you're just starting out, start from a really big prompt or a mega prompt, put everything together, work on that. And once you get to a certain stage where you know you can solve the problem and it's pretty good, but it's starting to fail, break it down. Why to break it down? The analogy that I love is like, if anybody remember, for those of you who did this when we were kids, like build dominoes, if you try to build like the entire domino line together, it's really, really hard because you tip one domino and then it topples all of the other dominoes. But if you try to build it in silos, and then at the end of the day you connect them, that's a much better strategy. The same that applies to dominoes also applies to prompt engineering. You wanna, at a very early stage, break it down and start optimizing different parts of the prompt. For that, you have to be able to evaluate, and there are a lot of optimization strategies, but that's the overall objective of how to do proper prompting. Now, there are 3 different levels of techniques, so to speak, for doing prompting. There's basic, there's advanced, and then there's tips and tricks. The basic, you'll find a lot of different lectures on YouTube. As I said, I have one as well, showing you kind of the structure, the 5 things to put in a prompt, the 7 things to put in a prompt. I specifically think there are 8. Really must-have things. You can't do without them. You're missing out on a lot of value that you can extract if you're not leveraging it. Then, advanced techniques. These are normally based on papers, and papers around NLP have been around for quite a while. There's a lot of interesting ones all the way back from 2020, even before we had ChatGPT. There are a lot of techniques. Some of them are quite hard to leverage. And last but not least, there is kind of the tips and tricks section. The thing is that the tips and tricks offer incredible cost value, and we'll talk about that in a second. So, basic technique. Everybody has the acronym for the basic technique. We at Latent love to use the respect one. First of all, because it's highly memorable. And second of all, because I think it covers all the relevant things. So, first of all, role. We'll see an example of that in a moment, but if you just tell the LLM what kind of role you want it to imitate, you'll add a lot of benefit and you'll really change the outcome. Second is example. I love talking about this because many a times when customers come to us, they say we try to do something, but we weren't really able to be successful. I say, did you use examples? And if you haven't used examples, go back, try to use examples. Structure, we'll see exactly how to control the structure. Pipeline, that is again a kind of wink at start with a mega prompt and then break it. And the two last one are very intuitive. Constraints, you have to tell the model the boundaries of how you want it to behave or how you want the output to behave. And the last one, the task. You literally have to tell it what you want it to do. Just 3 more slides, and then we're going to go see some demos. The advanced techniques, as I said, there are a lot. They're based on papers. Some of them are a must-have, such as like a chain of thought or step-back prompting if you're solving. Every now and again, there's a survey kind of detailing all of the different prompting techniques, which I recommend kind of every Q or so going over and looking at. Chain of thought is one of maybe the most influential one. It's so influential that when Google or any company that develops a foundational model releases a new model, they don't benchmark without chain of thought. That's how instrumental the technique is. Another one is step-back prompting. We'll see an example of that in a moment. This is a technique that, again, when it's relevant, it's essential because it improves over chain of thought. So however instrumental chain of thought is, and in some of the examples, it can add 30% plus in performance. Step-back prompting can get you another leg forward. Do you now need to go and read all the papers and kind of put them all together one after the other? Definitely not. Last slide before we jump over to do 15 minutes of demo. Tips and tricks. Why do I show these? Because sometimes you'll be like, I just want to prompt engineer. I'm going to stick to the basics. Basics are great. They're important. Advanced definitely offer a lot of value, but there's not always time to put in the effort to do them. There are a lot of tips and tricks, by the way, and this is not a comprehensive list. It's not like there are only like 4 different tips and tricks. The thing about tips and tricks, that some of them are just so cost efficient that it's crazy. So we'll see this in a moment. You can do chain of thought by, we'll go over what it is, but you can also kind of do a cheap chain of thought by saying, let's think this step by step. Or there's a paper called like emotional stimuli, which is the last one, and all you really have to do to take leverage of this is do something of the sorts of like, my job really depends on it. It's sort of like almost irrelevant what prompt you're writing. As long as you add this, you're probably going to get a performance increase. And it's that easy to do this. Great. Now, let's go over some examples that I prepared. So, the first one is I really want to show this in practice, that every word really affects. So now, I have the same prompt, but 4 different ways. The first, I put current, then current C, electric, and every time I run it, I'm going to get first of all, for the one that says current, I'm just rolling the dice. Sometimes it's going to be electric, sometimes it's going to be times, whatever. And for the rest, which are explicitly mentioned, like the direction or the way I should complete the prompt, they're always about a completely different topic, and that is just goes to show you how effective or how impactful each word can be. Now we're going to talk about the basic framework of like respect, okay, which is role, example, structure, pipeline, constraints, and tasks. First, role. All I have to do is, again, change one really simple thing, and I'm liable to get a completely different answer. Here twice I use first time scholar to historian, and I get a much longer answer. And in the second one, I'm using the role of a rapper, and it's sort of like concise. You can see that it has rhyming, I think, strategy and so on and so forth. And that's only like the small version of it. Normally when we give the model a role, we explain what type of role it is. It doesn't only affect the formatting or whether or not I have rhyming. It can also affect the method to solution. So if I say you are a mathematician, the model will behave in a different way. It will think more methodically, more logical. It will take more intermediate steps in order to try and solve it. Examples. This is super important, and the following is going to demonstrate it. What I'm asking the model is to classify into 3 different categories. And in my head, only in my head, A is fish, B is beef, and C is vegetarian. Now, when I tell the model your task is to classify products into A, B, or C, and then I say product broccoli, and I let it kind of fill it, it doesn't matter how many times I'll run it. I'm going to get A because it has really no idea. It's guessing. I can teach the model the logic by explaining it explicitly and saying, oh, you know, the A is for fish, B is for beef, and C is vegetarian. It's going to work. It's not really interesting because this is a pattern that we as humans see very clearly. And it's really nice that the model can emulate it. It's much interesting when I don't tell it the pattern and I let it identify on its own. A very good method to do is to use few short examples. And here is the same example. I'm asking basically the same thing. Your task is to classify. And I've generated, I think, 9 different examples of tuples with salmon A, tuna A. And you can see that there's a one-on-one correlation with the A is fish, B is beef, and so on. And now, when I run it, I'll always get C. I haven't told it that C is vegetarian, but I'm asking about broccoli, and I've given it, in this case, enough examples. How much is enough examples? Not going to talk about it now. It's obviously use case specific. It depends on how representative your example set is and what is the distribution and outliers in the data set itself. Next up is structure. Now, with structure, it's kind of a twofold thing. First of all, and this is my recommendation, in the prompt itself, use tags in order to divide the prompt to make it more understandable to the machine. It also allows you to control things really easily. And here, I'm just giving a product description, and I'm telling it to extract the name, size, price, and color from the actual description. And it's very, very obvious that if I reference a tag and the tag exists somewhere in the prompt itself, this is what I mean. Again, this example might seem trivial, and I will say that if I give it without the tags just as is, it's still going to work. But matter of fact that in production, prompts can be up to 64, even more pages long. The largest context window is millions of tokens, not something that you can read, something that can be very confusing to a machine, and it's good to get into this practice of making things organized so that you can understand it and the machine can understand it. Great. Next up is breaking things. Now, this again is kind of self-explanatory. I've given a very long task that's comprised of different things. I've written a very long prompt. If I wanted to go figure out if this prompt is good or not, I could, but ultimately I told you it's a very good strategy to break things up. This code is kind of abbreviated for the sake of showcasing. So if I'm trying to write a blog post, I probably want to do the following steps. I want to generate some information. I want to control the writing style. I want to give instructions on how to write a blog post, and best practice to always validate the answer that you get. So here I'm just kind of running this one after the other, and what this allows me in practice is to kind of single out a specific section. In this case, let's say it's the writing style, and I can now start replacing the writing style. I can change it. I can see how well I'm able to affect the writing style, something that would be much harder with a larger prompt, and this makes it much easier. Next up is constraints. I have to tell the model what are kind of the boundaries that it's working with. Because I said, I bring you back to this graph that I showed at the beginning. Only a subset of answers is what I'm actually interested in. And here is an example from similar to an opportunity that we're working on, creating a scheduling for guards or surgeons or whatever. If I just say, okay, write a guard schedule for 3 people and 2 guarding posts, I get something all the time, but basically every different time that I run it, I'll get something else. And I want to be more specific. I want to control the things. So at the end of the day, if you remember the graph that I showed at the beginning, I want to end up in the subset of right answers and not hallucinations. And here, if I say each person must guard for 8 hours, each person must have 8 hours of rest, you can already see that in the answer, it tries to account for rest. I'm not saying that it did it successfully or unsuccessfully, but it takes it into account once I mention it. I want to jump now and show you some of the advanced techniques. Definitely not all of them. And one thing, before I was using GPT-4, and now I'm just using a different model. I'm using Olama, which runs a server locally on my computer. I'm going to take Gemma 2 and take a small model. And the reason I'm using the small model is I want the examples to fail. And it's become very hard in recent times, and that's a good thing, not a bad thing. It's become really hard to make GPT-4o fail on trivial examples, even 3.5. So I'm taking kind of a lesser model in terms of capability. So let's kind of see 2 advanced techniques. First of all, chain of thought. You can see the example from the paper, and then we're going to see one in practice. On the left is without chain of thought. I give a question for a short calculation, and I give the answer, which is 11. It is the correct answer. Then I give another question, and I get the wrong answer, or they got the wrong answer in the paper. Once they corrected it with chain of thought, which you can see added in the blue section, what it does is it details the way of thinking or the process in order to arrive at the solution, but the underlying answer is the same. Okay? It's still the answer is 11. I've just detailed how to arrive at that solution. And 2 things happen, 2 things. First of all, they get the right answer, which I would say is the most important thing. And the second, which you can observe here, is that it's emulating exactly what the prompt did. It's trying to go through this chain of thought. Here is an example, the first one, and you don't have to read it. The first one, it's the same as you saw before. The first one was without chain of thought. The second is with this section of chain of thought. And you're not, you can actually see it. My screen is lesser. Without the chain of thought, it arrives at a wrong answer. And with a chain of thought, it arrives at the correct answer. And again, don't think of these things in the context of this simple example. Think about them in the context of production and what you're actually trying to achieve. It's much larger body of text. It's much harder to see the pattern. The chain of thought may not be this simple. What I'm showcasing here is something that is small enough to be relatable. The last kind of advanced technique which I want to mention, there are obviously many more, but I won't go through them for time's sake, is reverse engineering. I love this technique, especially if you're starting out. On any workshop that we do, we always have people use this technique. Okay, we're not against the new technology, obviously. We're a shop doing generative AI. This is a great technique. Why? You can use GPT-4o or any of the stronger models and have them create the prompt template for you. And it's a very good starting position. Why is it a very good starting position? Because they're better. Okay, they're better, especially if you're just starting out prompt engineering. GPT-4o knows how to prompt engineer. So what can you do? And this is a very basic example. I'm trying to, again, create a blog post according to a specific format. So let's say I really like Tony Robbins, which is a self-help guru. I just go and I saw one of his blog posts, and I really like the way that it works. I could kind of analyze it and see how it's built and the structure and everything and start kind of writing the prompt, the details, so that I could copy it with a different topic. Or I can copy-paste it into GPT and ask it to give me the prompt for writing such a blog post, which is what I've done here. Reverse engineer a prompt that creates a blog post similar to the following blog post. And then I get something and I can go on to use it. By the way, I'm going to make these notebooks available to anybody who wants. Last but not least, I'm going to go through two more examples. We spoke about tips and tricks. Chain of thought, very impactful, but sometimes hard to do. If you want to give a chain of thought, let's say for 1,000 different examples, it might be a lot of work. You might not have the time. Here's a trick. You can simply append to your prompt. Let's think this step by step, and you are liable to get almost as good performance as actually providing the chain of thought on every different example. So that's kind of one trick. Another is here, an emotional stimuli. So I'm just asking for investment advice. And if I say, should I invest in CVS, which is a super farm in the United States, if I just ask it, I get sort of like an answer. It's every time going to be something different. And here when I say, should I invest in CVS, and I add, my job really depends on it. And again, my focus here on like the effort that is required to put in order to change the outcome. We're not actually going to go into like how better this answer is than the other one, but you can already see that it's put more effort into it. Great. There's obviously a lot more examples that I could go into, but I won't for the sake of time. I hope I've given you a short taste of, first of all, why it's really important to know how to do prompt engineering, and also the various kind of avenues that you can try and progress in order to get it. One recommendation, which is not on the screen, but I'll say, I really recommend starting out by seeing what other knowledgeable prompt engineers have done, And one really good way to do this is with the different various hubs that exist. Anthropic has a really nice hub of a lot of different use cases and the prompts around those use cases. Go inside, see the prompts, try to analyze them, try to learn from them, and best of luck prompt engineering. Thank you very much, guys.